We'll make a recording. All right, so today should be pretty light because you've taken calculus before. Increasing and decreasing functions. You guys, what makes a function an increasing function? The slope is positive, or the slope of the tangent line is positive. So if I were to put that in calculus language, that would mean the value of the derivative is positive. So in other words, f prime of x is greater than 0. Yes? And likewise, what makes a function a decreasing function? The derivative is less than 0. So we're going to be doing some first derivative test type things to finding max and mins, because as we were saying whenever last, a function has a maximum when it switches from increasing to decreasing, right? Or when the derivative switches from positive to negative. Everybody good? So my gut is telling me that for the most part, we will be looking for, we'll be spending more time talking about what are my expectations and communication of your answers, because it should feel pretty darn familiar. Okay, find all the relative extrema on the open interval 0 to 2 pi, which means if I'm on an open interval, the endpoints are not extrema, right? Because they're not, we don't actually include them, so we keep getting closer and closer and closer to them without them ever being hit, okay? So here's what we need to do. Find the derivative, yeah? What's the derivative of 1/2 x minus sine x?
1/2 minus cosine x.
All right, so the next thing we're going to do is decide where on that interval is the value of this positive versus negative. Can we all agree that you can't go from negative to positive without passing through 0? Okay, so what we find those critical values by setting it equal to 0, and that's where any changes in the value of the derivative would happen. Okay, if I add cosine x both sides, I've got cosine x equals 1/2. Holy moly. Where is cosine equal to 1/2? Pi over 3 and 5 pi over 3. Everybody good so far? Okay. So to do my derivative test, I'm going to start with a number line, though I kind of cheated here. I'm going to have my number line go from 0 to 2 pi, and I'm going to put in just those places and you guys, so as I do my number line, if the function is continuous everywhere, I would have arrows going in both directions here. Okay? In this case, since we're only on the open interval, my number line only is that interval. Okay? And as we look at these values, are you guys with me that these are all x values? Okay? So I would like that labeled. Then what we're going to do is say, what do we know about the value of the derivative? So my next, we're going to put positives and negatives in here, and I want you to tell me that's the value of the derivative. At pi over 3 and 5 pi over 3, what's the value of the derivative? 0. So next, in between 0 and pi over 3, is the value of the derivative positive or negative? So here's what we're going to do. We're going to pick anything we want. What's a value in between 0 and pi over 3? You could say 1, but I don't want to plug 1 in here. Do you guys see what I'm saying? So I'm going to pick pi over 6 because I like pi over 6. And I'm going to do 1/2 minus the cosine of pi over 6. I don't need to know the exact number. I just need to decide, is it positive or negative? So you can plug it into your calculator. You don't need to give me the answer. You just need to know you just need to decide, is your answer positive or negative? Now, cosine of pi over 6 is root 3 over 2, 1/2 minus root 3 over 2. I know that 1/2 is smaller than root 3 over 2, so I believe my answer will be negative. And then I would like you to tell me, what does that tell me about my function? It is decreasing. We getting the basic idea here, y'all? Okay. And what's an angle in between pi over 3 and 5 pi over 3? Pi's the one I would pick. That seems significantly easier to plug into. What do we know about the cosine of pi? -1. So I'm doing 1/2 minus -1. Will that result be positive or negative? Positive, so I know increasing. And then if I chose 11 pi over 6, negative, decreasing. Okay, so the next thing we're going to state is we have a relative min. Where do I have a relative min? Where's the minimum? At x equals pi over 3. And this is where that justification is going to be. I don't know what AP and Turner required out of you guys. I'm going to ask you to justify, how do you know that's where your min is? You're going to say because f prime of x changes from negative to positive.
Do you need f of x at that point?
I believe all of my wording is find the x value where you have a relative, like on the assessments. I don't think I ever asked for that. The only time I might do that is if I give you that closed interval and I ask for like global maxes and global mins. That would be the only time I ask for that, which you would have to have, you would have had to have find those to know which ones are the globals anyway. All right. And then likewise, we're going to say we have a relative max at x equals 5 pi over 3 because f prime changes from positive to negative. And if you at some point start using like a plus sign and a minus sign, that's fine. If you abbreviate it to pos and neg, that's fine. You know what I'm saying? Like you're gonna end up writing it a lot. Everybody good? Cool. Let's look at it. Let's just look at some funky examples that might happen. Okay. What's my derivative? Everybody good? And I'm going to do some subtle changes here. Let's do I'm going to call that 4x over 3 times the cube root. And I'm going to do one more thing that's going to feel a little bit weird. I'm going to factor out that x squared minus 9 into x plus 3 and x minus 3. And the reason I'm going to do that is when we think through those critical values that we find, or where the function's equal to 0, or where the derivative is equal to 0, or the derivative is undefined, okay? And I think by factoring that out, I can see where that derivative is undefined a little bit easier. Okay, so if I set this then equal to 0, how can any rational function equal 0? Is when the numerator is equal to 0. Like a fraction only equals 0 if the top number is equal to 0. So to find where a rational function equals 0, and then I might say over here, x can't equal 3 or negative 3. So when I'm doing my derivative tests, okay, I still have 3 critical values that I'm worrying about. Does this make sense? All right, so in this case, my number line is going to be arrowed. The values I'm testing are negative 3, 0, and 3. Because again, I need to test wherever the derivative is equal to 0 or the derivative is undefined. Those are x values. So, if I put in, say, negative 4, what happens in my numerator? Negative. And my denominator is going to be a cube root of, let's see, negative times negative. Is everybody kind of seeing what's going on here? And does the cube root matter? Not really, okay? Because I can take the cube root of a negative, right? And then the cube root of a negative is negative, and the cube root of a positive is positive. So we can kind of ignore that cube root. So overall, is this value negative or positive?
Negative.
Which tells me f of x is decreasing. What about at negative 3? The derivative is undefined. The function is not. Is everybody good? The function is defined at x equals negative 3. Great. All right. What if I plug something in this region? Let's see, the top would be negative. This one would be positive. This one would be negative. So negative, positive, negative is 2 negatives is overall positive. What is the value of the derivative at x equals 0? Okay, next. And we're just plugging stuff in and checking. So, if you guys had to guess of what's going on here, what does it mean if the function is defined at x equals negative 3, but the derivative is not? I'm sorry?
Cusp.
A cusp. So we would expect kind of like a goes down, cusp, comes back up into a smooth, right? Because the derivative is defined here. And then comes down another cusp, and then goes back up. We just trying to make some sense out of all of that, right? Okay. and you can say like that's what's happening. Okay. I'm gonna add some extra directions here because I know how I word this on quizzes and tests. Okay. If I ask you what are the intervals find the open intervals on which f of x is increasing and decreasing. On what intervals is the function increasing and decreasing? Let's start with increasing. -3 to 0 and decreasing. Then we would say we have a relative min at x equals 3 and -3 because f prime changes from negative to positive. And then feeling okay? You guys want to try the next one? I believe there's a slight trick in the next one. I believe. Does anyone disagree with my answer?
Why is this one having a relative max? The other one did. Should it also be undefined?
What do we know? So I said it, but we didn't write anything down. If we look at x equals -1, okay, the function is defined at x equals -1. At x equals 0, I have an asymptote. So you can't have a max on an asymptote.
Okay, I see.
Is everybody good? So because,
Only the derivative.
so on this one,
I see.
the derivative is undefined, but the function is defined. That's essentially the difference. Now, the reason I pointed this out, and I did this in this manner, is I would encourage you guys for all of these, and I do this myself. You got a really handy tool sitting with you as you're taking these. After you, you're going to need to show all of this support, but the next thing I would do is say, I would graph it and say, does my graph match my answer? Because if you graph this, you'll see that asymptote and you'll be like, oh. Do you guys catch my drift? There's no reason why you couldn't. I would do the work first because you need to show all the support. You can't just use the max and min functions on your calculator to do this, okay? I would expect to see all of this as your analytic support. However, you should use your tools, and your calculator is one of your tools. Graph it and you'll see it. Everybody good? And does it seem like something I would do to try and trick you in this way? Does it really count if I tell you in advance this is how I would try to trick you? Does that count as tricking you still? I don't think it does. Everybody okay? You guys won't fall for it because I told you I'm going to do it, right? If I ask for intervals of increasing and decreasing, this aspect of no max wouldn't matter. Because we're still just looking where's the derivative positive, where's the derivative negative. You're not going to let me trick you, right? That'd be pretty funny. Ooh. Let's give this one a shot. So what should be jumping out in our brains right away when we see this? When I see this, I'm trying to take my derivative. This is a product rule question. We have to use the product rule here, okay? So if you need to write that out, that might help, I don't know. So for this one, to figure out where does this equal 0, you would want to notice that both pieces of my product rule have that e to the x plus 1, so I'm going to factor it out. Okay? And just a reminder that there's a 1 right here, so that's this 1, and then the x minus 5. we good? Do we all agree on the derivative? All right, where's that going to equal 0? Anywhere else? Can we all agree on x equals 4 is a 0? Anywhere else? What do we know about e to the x plus 1? No matter what value I plug in for x, it is not only that, because we're going to be doing some testing here, at e to the x plus 1, it's always positive, yeah? Because like a positive to a power is always going to be positive. Every good? Are we comfortable with this? Okay. All right, so if I pick a value smaller than 4, my derivative is positive here, negative here. Overall is negative, decreasing. I'm feeling okay? All right, so general picture of this would tell me I'm decreasing and then I'm increasing and that's it. So if I'm starting off decreasing on that left side of my graph, I'm pointing up forever. So there's not a max on that side. And if I'm ending up increasing, like my function's like this basically, yeah? So do I have any absolute maxes? What about absolute mins? Because my graph has to look something like that. Now, it turns out that it looks really funky. It looks more like this, with this being at 4. Okay? But, like, the left-hand side is like a negative exponential, and the right-hand side shoots up really, really sharply. Okay, but it's there. Okay? Questions? Tell me. Oh, great. We still have some more. Okay. All right. So what we have here is a graph of the derivative. So if I ask find the open intervals on which, and this is a graph of f prime of x. So f would be increasing when f prime of x is greater than 0. So basically I'm looking for where is this graph greater than 0. That would be this section. So negative infinity to negative 2. Negative 2 to 0.
Because when it equals 0, it's not increasing.
It's not positive. And then that looks like 1 to 0? Or 1 to infinity? So what would need to be happening there? What would that look like on our graph?
Like x cubed.
Yeah. Yeah. So at this spot right here, we're increasing less slowly, and then increasing some more. Everybody good? All right. Where do I have maximums? Where do I have minimums? So in order for something to be a max, we are looking where f prime of x changes from positive to negative. So where does my derivative change from positive to negative? Just at x equals 0. In order for something to be a min, my f prime of x changes from negative to positive. Where does that happen? So we have that like kind of weird shelfy thing at x equals -2. I have a max at x equals 0, a min at x equals... Is that the only way that graph could be drawn? No. There's lots of functions that would match this. That would also work, right? So anything that kind of has a shelf here, a max here, and a min here. That would be the only thing we know so far. Tomorrow we'll talk about concavity, where we'll start pulling in some other parts, okay? Everybody feel okay?